Hello, everybody. So today I'm going to go over an example with you that deals with chi-squared test for independence. Okay. So in this question right here, now if you had to give up an electric device, whether it be cable TV, home internet, or your cell phone, does the age that you are play a significant role in that? So here's the question. So which modern electric devices do you care most about? So a simple random sample of 100 people were asked two questions: their age, and if you had to give up one of the following three electronic devices for 3 months, which would you choose to give up? So only the people who actually owned all three devices were interviewed, and here are the results. So you can see that if you're in the under 25 group, you would be much more likely to give up cable TV. Whereas if you're over 50, you would be much more likely to give up the cell phone. And we can all attest to that. All right. I mean, under 25, most teenagers are under 25. Only three of them would want to give up their cell phone. So then the question becomes, is there an association between age group and which service people would give up? So when you're doing these kinds of tests, remember you need to figure out which test am I going to use. And for chi-square tests, it's a little weird because there's three tests and they all use the same test statistic. So try to look at where the sample is being obtained from. So because we're sampling from one group and then you're analyzing subgroups, you're going to want to perform a chi-square test for independence. And because no significance level was stated, we're going to use 5%. All right, so for every statistical test, it's always those same four steps. So we've already stated what we're doing. So now we're going to go into the hypotheses. So for the chi-square test for independence, the hypotheses really don't vary that much. It's always there is no association for the null, and there is an association for the alternative. So for the null here, there is no association between the age group and the service that people would give up. And the alternative, hey, there is an association between the groups and the service that people would give up. So let's go down and look at the observed versus the expected. So we're going to do that before we do the conditions, because remember, when we're dealing with conditions, large counts as one of those, and we need to make sure that our expected counts are all greater than or equal to 5. So with any chi-squared test, we're always comparing the two same things. We're trying to look at what we observe compared to what we would expect to happen given the data. So here are all our observed values right here. So the way that we would figure out the expected is we always do the row total multiplied by the column total divided by the overall total. So think about it like this. If you're under 25, okay, regardless of whether you chose cable, internet, or cell phone, there's 32 of you. And then there's 32 out of 100. And if you want to figure out how many would you expect to give up cable TV, because 51 chose that they would give it up, it would be 51 multiplied by that. And that would give you a value of 16.32. So in this example, we're going to have to do this 9 different times. Now that can be quite time consuming. So in another video that I'll post, I'll show you a much faster way to do it using matrices. But for right now, we put all these values, we multiply across, we divide by the total, and we get all our expected values. So if we take a brief look at everything, we notice there are some differences. So for example, the biggest one that comes out here is the cell phone for over 40. We had 14 people that would give up their cell phone, whereas in reality, we would only expect about 6.67. And then we have others that are maybe fairly similar. Cable TV for people between 25 and 50. We've got 20 there, and we expect it to be about 19.89 there. So those are pretty similar. But the goal here is to look at everything, bring it all together, and see what's going on as a whole. All right, let's first of all look at the conditions, and then we'll perform the test. So remember, there's always 3 conditions: random, 10% independence, and large counts. So for the random, remember we only took one sample of 100 people and it was a simple random sample, so that checks that off. For the 10% independence, we can assume that there are more than 1,000 people in the population. So we're 2 out of 3 so far, so that's good. Now for the large counts, remember, we want to make sure that each expected count is greater than or equal to 5. So if we look back here, the lowest one we have is about 6.67, so we can check that off the list as well. So that gives our results validity. So now let's go ahead and figure out the test statistic, and then that'll help us lead us to our conclusion. So remember, the test statistic is always the same, no matter whether you're doing goodness of fit, homogeneity, or independence. It's always the sum of all of the observed values minus the expected values squared divided by the expected value. Now, I'll come back to the degrees of freedom in a second, but for right here, we do want to show some work. We're not going to write it all out because that's a lot of different sums to write out. So show the examiner or whoever's grading your paper that you know at least what you're doing, and then you can use the calculator to come up with this value here. So let's just go ahead and do that, make sure we're all good with that. So we open up our calculator, we go to stat. So in the left-hand column here, I have all my observed values, and in the right-hand column here, L2, I have all my expected values, or my expected counts. Make sure that they match up. So the 24 for the cable TV under 25 has to match up with the 16.32 expected for the same cable TV less than 25. So once you've done that and you've matched everything up, go up and highlight L3, and we're going to plug in the formula. So open up parentheses, L1, that's all our observed values, minus L2, our expected value, square it, and then divide by the expected count. So second, L2. And that's going to give us all our values. Now remember, another name for these is also contributions. Like ones that have the highest value here will contribute to the test statistic the most. So those are the values that are going to really, they're going to influence whether we're going to reject or fail to reject our null. So if I go down to that one I was talking about, which was the cell phone for over 50s, you can see it's about 8.055. So that's pretty significant. That's going to be pretty influential. Okay, so let's go ahead and calculate this test statistic. So we get out of that. We're going to go to list because we want to find the sum. So we're going to go to math, and there's the sum there, number 5. Press number 5, and then remember all those contributions were in L3, so we do the sum of L3. And we get a value of 21.4988, and so on. So as you can see, I've rounded it to 3 decimal places there, 21.499. Okay, so now we want to figure out the p-value. Now you can get this using the tables, or you can get an approximate region of where it lies, but we want to be able to figure out the exact value. So this is where we're going to use the chi-squared CDF. So we go to second, vars, which is all the distributions, and then we go down to number 8. Now on this particular calculator, it's going to allow you to plug in the 3 values like this. On the older calculators, you have to put it in separated by a comma, starting with the lower, then the upper, then the degrees of freedom. So our lower value is 21.499. Our upper value, just make it some large number. Now the degrees of freedom. Remember, it's always the number of columns minus 1 multiplied by the number of rows minus 1. So in this case, it'll be 2 multiplied by 2. That gives us our degree of freedom of 4. Remember, for degrees of freedom with chi-squared tests, you're always using the categories, not the individuals. So we'll scroll down here, go to paste, and press enter. And there we go. Now, it's not 2.5. Look towards the end always. We've got e to the negative 4. So that means we have a much smaller value. So it's going to be 0.00025. So that's an incredibly small p-value. And it's much smaller than our level of significance of 5%. So that means our conclusion is we're going to be rejecting the null. So therefore, make sure you state your conclusion in context so there is sufficient evidence to suggest that indeed there is an association between the age group and the service that people would give up. And of course there is. I mean, kids, they're going to not want to give up their cell phones. Adults or anyone in over 50, they're probably going to be more likely to not really care about their cell phone. But heck, try and take away their cable TV and they can't watch their episodes of Jeopardy and Wheel of Fortune, then you got a problem on your hands. All right, so hopefully that makes sense. I will put together 2 more videos where I show you how to use the TI-84 Plus and actually the older version of the calculator as well to make this part much faster. All right, thanks very much for listening. If you have any questions, please just reach out to me. I'll be more than happy to help you.